Hi everyone. Thank you for joining our analysis for today. I hope that you can hear to my voice and also you can view my current screen, which is on the slide presentation. Okay, so let me go straight here. All right. So my name is Arina Asri, and I am the application engineer at acadsystems Berhad. And for today's topic, we're going to learn on how we can create a steel structure design using the robot structural analysis. Okay, so what is a robot structural analysis? So for you guys who didn't know what is the software or what are the function of the software, is that the robot structural analysis is one of the structural load analysis software which verifies code compliance and use BIM integrated workflows to exchange data with Revit. So basically, it will help to create more resilient, constructible designs that are accurate, coordinated, and connected to BIM. So basically, robot structural analysis is one of the analysis software. So this robot software we usually use to analyze our model so that we can check whether we can check the performance of our model. Like for instance, we have a structural model and then we want to check whether the beam that we use is okay or not, and then what is the shear, the tension load, and so on. So basically, we use robot structural analysis to check all those requirement or all those analysis. Okay, but for today, I'm going to show you what other things that we can do as well in robot structural analysis. So basically, we can create a model or a structure model using this robot structural analysis. So basically, before this, people usually use Revit to model their structure and also their steel design and so on, and then they will export to robot software to do the analysis. But this time around, I'm going to show you on how in robot software we can create the steel structure design using this robot structure analysis. So for the demonstration, what we're going to do is that this is the one that we're going to create. It's like a warehouse steel structure. So in order to create this steel model using this robot software, is that the first thing that we're going to learn is that we're going to input the material first. So basically, this one is more to setting on the materials that we're going to use in robot software. So basically, we have many standards in this world. Like for instance, we have Eurocode, British standard, Australian standard, and so on. So basically, before we start our project or before we start creating our model, we will define first what type of material that we're going to use, what standard that we're going to follow in order to create our project. Okay, so thank you to the one that just joined in our free online lesson. So currently, we are going to create a steel structure design using robot structural analysis. Okay, so after we have input all the material and all the material setting, then we will setting up the grid first. And then after setting up the grids, we will adding the section types. So in this adding section types, it's more like we're going to specify the members that we will add into the project. Okay, so for instance, you have your own maybe your own BIM section to use in this software to create the design, to create the model. So we can also manually type in the thickness of the web, thickness of the flange, the height, the base, and so on. So basically, we can manually input the numbers or the values that we require to create our BIM sections. Okay, and then after we have adding the section types and so on, and then we're going to model our steel structure. Okay, so I'm going to continue with my robot structural analysis. Let's see from here. Okay, right, let me share my screen first. Okay, so if you guys do have any questions or any issues, then you can just type in the chat section below, chat section, so that later at the end of the tutorial I will read your comments or your questions. Okay, so I hope you can see my Autodesk Robot Structural Analysis interface. I'm currently opening my robot software. So once you open the robot software, this is the interface that will come up. All right, so basically I'm going to create a new project. So to create a new project, if you see, we have the frame 3D design, and also we have building design, frame 2D design, and also shell design. So if you want to create a steel structure design, a steel structure, so you are required to use this frame 3D design. But if you want to model a structure that is required, maybe you need to locate or place some concrete structure, so that one will be building design. Okay, so if you want to go with a steel structure design, so this one will be you need to use this frame 3D design template. Okay, now I'm going to click on this frame 3D design. All right, as I said just now, the first thing that we're going to do is that we're going to input the material first for our to create, before we create the model. So for the material setting, you can find it under tools. We have here tools up here, and then that will be on the job preferences. Okay, all right, if you click on the preferences here first, I'm going to click this one. This one is more to standard, so that one is applied to you if you want to use other type of standard, like for instance you want to use British standard or Australian standard, so you can just choose the regional settings here. Okay, we have Australian, we have like United States, so on, so you can just choose here depending on the region or country that you want to follow. Okay, so I'm going to click on the Euro code. Right, so for this project today, I'm going to use the Euro code standard, and I'm going to click on accept here, and then the next one is for the materials, so I'm going to click again on tools and click on job preferences. Okay, so in job preferences we have these materials. So I click on these materials, and then if you see the materials here, we have a few more country that we can choose. So this is more likely for the standard that we're going to follow or choose. Like for instance, if you want to go, if your project need to follow the British standard, then you need to change the materials here to British. So once I change this into British, and if you see, the basic set here also will be changed automatically. So this one has been set in robot software. So once we change the country here and the materials here, it will also be changed automatically for the basic set for each of the elements here, like for instance steel, concrete, aluminium, and also timber. Okay, so for instance I change to Japanese here, then it will change as well this basic set. But you can always change this basic set. Like I click again on Euro code here, and then I click on steel, and I have a few more types of basic set here. So I'm gonna go for S235. All right. So another one is that if you want to create a new standard, like for instance under this Euro code here, you want to create another one, like maybe S500 or the S500. So what you can do is that you can always go to modification. So I click on this modification, and then if you see under steel here, we have the name here as 235, and then we also have the information or the values for each of the information here that we have here. Like for instance, the Young modulus, Poisson ratio, shear modulus, the resistant characteristics here is more like to a yield strength. So for instance, just now I said to you, I want to create a new one, which is maybe S500. I want to make the yield strength to be 500 megapascal. So I can always create a new one by clicking or by inputting the new numbers here as, for instance, as 500, and I can click add. I click add, and then I can change this one into 500. Okay, so once I drop down this one, I already have the S500. So basically, for this material definition here, you can always change the information of the Young modulus, the yield strength, the tension, limit strength for tension, for shear, and so on. Okay, so I'm going to click back on S235 here. I'm going to use this Eurocode standard. So I will go for S235. I'm going to click on OK. All right. And then on the design code on the left side here, click on the design code. So this one is also the standard that we're going to use for our model in this project. So basically, if you want to change these standards to your own country, maybe you want to use other country standards. So you can always, if you can't find it in here, you can always click on more, and then in here we have these codes, the design codes for other countries. So like for instance, we have for Japan, France, USA, and so on. So you can always choose from here. Okay. All right. So this one, I'm going to leave it like this. Leave it on this code. Okay. And I'm going to click on OK. All right. So that is for setting up the materials and inputting the materials following our preferences. Okay, now what we're going to do is that we're going to model our steel structure. So the first thing that we're going to do is going to create the grid first. So to create the grid, on the right side here, okay, we have the axis definition. So click on the axis definition. All right, and then on this axis definition here, if you see, we have the X, Y, and Z axis. So we need to specify the number of grids and also the distance between each grid for each axis that we have, X, Y, and Z. Okay, so for X here, we want to make the total length of the axis, total length of the grid will be 30 meters. So that one will be and I want to divide it by 6 grid. So the number of repetition here will be 6, and the distance between one grid to one grid is 5 meters. Okay, when I click add, and then here if you see, we have the total length of our total length of our grids is 30 meter. Now move on to y-axis, and the y-axis here, the number of repetition here, I'm going to make it 12, and the distance will be 6 meters. And then click add. Okay, the total length will be 72 meters, and then the z-axis, let's add first the position starting from 0, and then the second level. This is for z-axis, so that one will be the z direction. So the second level will be 8 meters, and number of repetition is 1. Click add. Okay, all right. So delete this one first, and then the next one, this one will be 0. Then the next one will be adding 2.5, so that one will be 10.5. I'm going to click add. So this is for the z-axis. So after you have done with the axis, adding the axis or adding the grids, and then you can click on apply. So once we click apply, this is the axis that we want. Okay, the X, Y, and axis grids. All right, so let's close first this structural axis. All right, now we have done with the axis, and then the next thing that we're going to do is going to create the section types for our beam and column, steel beam and column. So that one, to create the section types for the beam and column, on the right side again, we have this member section. So I click on the member sections here. All right, and if you see, these are the members that that we have already in this project. So basically, I want to create my own section or my own size for the sections. So I'm not going to use these 5 types of section here. So I can just delete this one by clicking on the scissors symbol here. So click this one and then delete all. All right. To add a new section to be used in this project, you need to click on the new section definition. Okay, once you click new section definition, this one will appear, new section bar will appear. And then in here, I'm going to use the parametric. I'm going to specify or define the dimensions manually. All right, I'm going to click on the parametric, and then the shape that I'm going to use, or the section type I'm going to use, is the I section. Okay, and then on the dimensions here, we need to specify first the dimension for each of this information that we have. And then on the label here, we can always rename the new, because this is the new section that we're going to create. So basically, the label here, we can always create following our preference name. Like for instance, you want to rename it as maybe you want to create to rename it as by the size. So like for instance, 600 by 500 by 200. This one also can. All right, but for now, I'm going to rename it as first as this C1. C1 will be column 1, C1. All right. And then the base here will be 150, and the height of web will be 300. The thickness of web is 5, and the thickness of flange is 6. And then I'm going to click add. So once you add, and then it will be stored into our section here. Okay. And then I'm going to add as well for the beam. That one will be B1. And then for B1, the dimension also will be the same as the C1. So I can just change the name, and then I can click add. And then the next one, I'm going to use the tapered here. And then we're going to use the I-beam here. This one will be C2, column 2. And the base size will be 200. And the height will be, the start will be 300. And it will end 800 millimeter size. Okay, so I just noticed that the dimension that we use currently is in cm. So that one we need to follow in cm. So we need to change this one to 20, and this one to 30, and this one to 80. Okay, and then for the thickness of web, that will be 0.5, and thickness of flange will be 0.6. And then I'm going to click add, click close first, and then I'm going to click close first this one. So to change the units, is you can go to tools here, and we have units and formats. So I click units and formats, and then on the section dimensions here, you can change this one into millimeter. I'm going to click on OK. And then I go back to my member section. And if I click on the B1 here, all right, so if you see that one have been changed to millimeters, so we need to change the numbers here. This one will be 150, this one is 300, this one is 5, and this thickness of flange is 6. And then I click add and change. Okay, and check again on the C1 also, we need to change 150, 300, 5, and 6. Click add and then modify it. All right, so C2, I think this one is okay. And then let's add some more the members or the sections. So click new section definition, separate. I'm going to use this one I section. And then the next one is the B2. Label is B2. And the start is 200 by 200. The height of web is somewhere around 500. And this one is 800. And then the thickness of web and thickness of flange is okay. And then I'm going to click on add. All right, so the last one that we're going to add as well is B3. All right, before that, we need to use parametric first. Okay, and then I'm going to click on this one. This one, I'm going to use the I-beam here. This will be B3. And the base is, let me see, this one will be 200. The height of web is 500 and the TW is 6, TF is 5. Sorry, this one will be 5 and this one will be 6. I'm going to click add and close. And then this one also you can close. So now we're going to create our steel model or steel structure. So to create the steel structure, click on members on the right side here, and then choose the first one will be C2. Okay, and then I'm going to add this one to here, on this side as well, from here up until here. Okay, now I'm going to close first this one. So if you want to see the real beam, so you can just go down here. We have the section shapes. So click that one, and then this is our column. Okay, and then I'm going to change this one to XZ, and then change this one into structure axis 2. Okay, so this is our column. Now we're going to add beam. Click on members again, and then change this one into B2, beam number 2, and then start from here to the center here, and then from here to here. Okay, so that is how we create our steel structure. And then what we can do is from here we can copy all these structural elements to other grids. So I'm going to click on this one, select all these 4 elements, and then to copy them is it will be under edit up here. So click on edit. I'm going to bring edit to the right side so that I can see the symbol easily later. So click on these copy and move. Okay, translation. Now we're going to copy, and then the number of repetition is 10. And the translation vector is starting from here to the second one. So it will automatically generate the elements to other grids because we have specified the number of repetitions here. Okay, now let's add as well on the first grid and the last grid here, we'll use other types of beam or section. So again, I'm going to click on the, before that, change this one into XZ view, and then change this structure axis to structure axis 1. And then let's click on the members. And then this one will use the C1. Okay, click on C1. Start from here to here, and from here until here. And then for the beam, I'm gonna use the beam one, B1. Start from here to here, and from here to here. Okay, so that is for the beam. We're going to add as well, and again C1 on this grid, on this center grid here. So start from the below and to up here, from here to here. Okay, and if we go to our 3D, so let me change my view to 3D. So that is our grid. So basically we have access column here. So we need to cut, or we need to trim this column. So to trim them is that, again, up here we have the trim. Beside the intersection, we have trim. So click on trim, and then selection of cutting object. So the one that will cut, cutting object will be this one as a reference cutting object. And then the object that we want to cut is this 1, 2, 3, 4, 5 column here. Okay, now to cut them is, we need first to select, if we will select the below one, then the below one will be cut. So you need to carefully select the upper one. So click on the upper here, and then it will be cut automatic or trim automatically. So click on the upper one, and this one as well, and also this one. Okay, and then the next one that I'm going to do is that I'm going to make, okay, this one I'm going to close. Okay, the next one I'm going to do is that I'm going to make this column to rotate to 90 degree. I don't want this one to, this column is currently like this. I want to rotate it to 90 degrees. So what I can do is that I can go to geometry, and then click on properties here, and then gamma angle. So I click that one, and then special values here, I'm going to change to 90 degree, and then choose the column that you want to rotate. Like for instance, I want to rotate this 5 column here. So just click on this column, click on this column, click on this column as well, this one, and also this one. So basically we have rotate our column to this side. Okay, that is how we can create, we can rotate our column or beam in robot software. Okay, so when you have done with this one, now let's copy all these. Let's go back to XZ, going to select all this, and then go to 3D back. Going to copy again, copy, move or copy. And the number of repetition of this one, because we just want to copy on this side, and then start from here, and the last one will be here, and then this one will be automatically copied to the last grid. Okay, so let's add some more the purlin on our structure model. So to add the purlin is going to create another section. This one will be a small section. I'm going to click this new section, parametric, and then it will be using the I section. And the HW here, I'm going to change to 150. And this one will be B4. Click add, close this one and close. Now go to members. Click on B4, all right? This one has been changed to B4. And I'm going to start to add the purlin. So start from here to here, and then here to here, and then I'm going to choose the center here to this center, and then to the center as well to here. Okay. All right, and then we can just copy and move all these members. Select these 4 members, and then click on copy, move or copy, and the number of repetition will be 11. And I will go start from here to here. Okay, now we have created our purlins, and then this one as well. I'm going to copy. Okay, this one, copy, start from here to the last here. Okay, now our structural model has completed. Okay, I think we have checked that. So for the question, can we export Revit model to robot structural analysis? Yes, we definitely can export Revit model to robot structural analysis because usually we will model in Revit, and then to do the analysis to check whether the model is the structure model is okay or not, how the performance of the structure model, how we can have the tension and the loads as well. So we need from the Revit we need to export to robot structure analysis to do the analysis checking. Okay, all right. So that is how we can create the structural design or steel structural design in robot software. Basically, we can also adding the connection. So that one will be in my next free online lesson, because for the connection it's quite the lesson will take a very long time. So I need to do that one in another session or another free online lessons. Okay. So all right. So thank you so much everyone for joining for our free online lessons for today. I hope to see you guys soon in the future. Okay, and yep, I think that is all from me for today's free online lessons. And yep, okay, take care everyone, stay safe and bye-bye.